Hello, so in this video I will show a step-by-step solution to solving for the rate constant given what values you were provided in the question stem. So going back to your question, half-life of 276 seconds and initial concentration of A, the not means initial is 0.725 molarity, or molar, which is mole per liter. And then the question asks the rate constant K at zeroth order. So I'm going to reduce this up there. So these are our givens, and I'll go ahead and solve the problem. So I know that time equals to the initial concentration minus the concentration of our species divided by the rate constant K for zero order reactions. The half-life is equal to the initial concentration over 2K, because the concentration will be 1/2 of what it was initially. So plugging this in to that leads to this. So then I can plug those in to the equation to get the half-life is equal to initial concentration over 2 times the rate constant. And then you just need to isolate, you just need to isolate the rate constant K. So I multiply both sides by K. Then I divide both sides by half-life. So then our rate constant K equals the initial concentration of substrate A divided by 2 times their half-life. And given our values up here, the initial concentration of A is 0.725, and then the half-life is 276 seconds. 276 times 2, let's see, 250 times 2, 300, and there's 26 remaining times 2 is 52, so 600, let's see, 250 times 2 is actually 500, and the remaining 26 times 2 is 52, so it should be maybe 552. So 725. Okay, so this is going to be something as 725 times 10 to the negative 3 in scientific notation divided by 552. So maybe I can estimate and do 725 divided by 550, and then divide them both by 25. Or just leave it, because I know that it should come up to around 1.2 times 10 to the negative 3. Because I can think about just doing 700 over 500, erase that. It's about 7 over 5, which would be like 1 2/5. One and 2 over 5. So that would be like 1.4, but it's a little bit less than that because it's actually 725 over 552. So this is plus 52. This is plus 25, so my estimate was plus 25 over plus 52. So it should be a little bit smaller than 1.4. So that's how I know it should be right around